Hi there. Thanks for joining us on another episode of Space Nuts. My name is Andrew-dunkley, your host, and great to have your company, as I tend to say. Well, if I ever say it's not great to have your company, you know we're done for. Now, who was that voice in the background? Now, we've got a lot to talk about today, and one of those things is the future of Fred. Yes, Fred's future. It's about to change. Is he leaving us? Ooh. I'll tell you in a minute. Artemis 3 landing sites have been announced. There are, I think, about 9 of them. We're going to look at some new data from the asteroid Ryugu, which could shed more light on how life ended up here. And a study of Saturn's moon Titan. They're saying it might rewrite planetary science. That's a biggie. All coming up on the next episode of Space Nuts. Right now.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And here he is to tell all, Professor Fred Watson. Hello, Fred.
How are you doing, Andrew? Good to see you again.
Good to see you too. My question should be, how are you doing? Because today's a big day for you.
It is, yes. It's a day of some note in my life. But the story starts actually on the 16th of July, 1973, when I became a staff astronomer at the Royal Greenwich Observatory in the United Kingdom, because that is when I joined the British Public Service, and effectively, I've been there ever since, except it switched to the Australian Public Service in 2010. So I've been a public servant, Andrew, for 51 years and 4 months.
My.
And it comes to an end today.
So what's happened?
So my role as the nation's astronomer, the Australian government's astronomer at large, which I've had since 2018, so it's 6 years that I've been in that job, is coming to an end. So I am going to leave the public service. I'm not leaving astronomy. I'm moving to a new role in one of the universities here in Sydney, which I'm extremely excited about. But it means that I'll be able to, certainly be able to carry on with Space Nuts. Nothing will change there. But it also does mean that from outside the government, when you're working not in the government, but you're working outside, you might be able to have more influence, believe it or not, in terms of advocating for the way we hope Australian astronomy will go, getting the message out that astronomy is a good thing and that people like it and want it to be supported. All of that's easier to do outside the government than inside. So in that regard, it's a good thing. I'm sad about it, of course. 31st of October 2024 is as notable as the 16th of July 1973. So it's what I guess I'm sad about is the colleagues that I've worked with over the last 6.5 years, 6 years and 4 months. Fabulous bunch of people. Public servants are they're a breed on their own, I guess. They essentially, provide all the information that a government needs to make up its mind on its policies, and they are very, very professional about it. And they're nice people. I've made some great friendships with people down in Canberra, which is where I've been based, although I live in Sydney, so it's all been done over the internet. But yeah, so we had a little party yesterday. I was down there yesterday, drove back yesterday afternoon. We had a bit of a celebration, some cake and nice coffee and things like that. And they bid me on the way. There's another one today, actually, the last day. In fact, immediately after this podcast recording, I'll be joining my colleagues online just to say a virtual farewell to the ones who are scattered over the country. There are people in Western Australia, South Australia, all over the place. So,
wow. Gee, it's the end of an era, Fred. And I say congratulations, first of all, for all of those decades in astronomy and surviving that long in the public service. That's a feat in itself. But I suppose the good news is that you are not retiring. We want to make that a very solid point. This is not the end of your astronomy career, because if it was, you'd go from being an astronomer at large to a large astronomer.
Oh, yes, that's probably right. I would, yeah.
Yes.
I actually should just highlight one of the jokes that one of my colleagues made quite some years ago when I was the new astronomer at large, because I sent them a photograph. I skipped out for lunch down on the beach one day here in the Northern Beaches, and came back and talked to them online and I said, this is where I had lunch. And this gentleman, his name's Ben Scandrett, really nice guy. He said, "Oh, you're the astronomer à la plage." Turned it into the French version, astronomer on the beach, which I quite liked.
That's very funny, yeah. And just to prove the point, that's not a door behind Fred. If you're watching a video stream, that's actually a very well disguised Malibu surfboard.
It is, yeah.
In a wood grain finish.
Most people don't notice that.
Oh. That's why I'm in journalism. Yes, got to pick up on these things. Well, we wish you well, Fred, and there'll be more to announce down the track when things start to shift. But it's been a wonderful, wonderful public service career, and you should be very, very proud. And I'm glad I was able to be a part of that for a few years as well.
Nice to hear, Andrew, and thank you very much for that. And I mean, you and I are going to go on forever probably, so that's all right.
Yeah. We're planning on a couple of billion years because we so much want to see that collision between Andromeda and the Milky Way galaxy. So we're hanging on for that. Some other exciting news is, and this sort of falls at the same time as China has launched a mission to test moon bricks for their future base up there. The race back to the moon is really ramping up, and the Chinese, I think, have fired a pretty heavy volley that NASA needs to respond to. Well, I don't know if this is their response, but they've certainly made a major announcement. They've looked at key landing sites for Artemis 3.
Indeed, they have, yes. So this is not really a response to anything. It's just part of the process that the mission planners go through when you are planning something as big as Artemis 3, which people will remember is the first landing of humans on the moon since 1972, and will have 4 NASA astronauts walking around the South Polar region of the moon. And that's what makes this challenging, Andrew, because, all the Apollo landings were in the mid-latitude region of the moon where the landscape is relatively flat. There were mountains there. There were a few sort of highland peaks that they landed on. But the South Pole region of the moon is quite different. It's very, very pockmarked with craters, a lot of mountains, a lot of, evidence of past geological history. And, of course, that's one of the reasons why they're going there, to be able to sample the geology of the moon's South Pole. So the landing zones that have been identified, what they've done is they've sorted them out, taking into account factors, and I'm quoting NASA here, factors in the selection process included science potential, launch window availability, terrain suitability, you don't want to land on a mountaintop, communication capabilities with Earth, and lighting conditions. So all of those things have to go in the mix.
What was that last one? Lighting conditions.
Yes, that's right, because you don't want to be working completely in the dark, and you could be if you're at the moon's South Pole.
Worked out okay for Pink Floyd.
It did, yeah, but they were in a different universe, I think. So it's all right.
Probably still are.
Yeah. So actually, I might just continue the quote from NASA, because it's a nice way of doing this. Additionally, the team assessed the combined trajectory capabilities of NASA's SLS, the Space Launch System rocket, the Orion spacecraft, that's the crew module, the equivalent of the Apollo, the Apollo crew capsule, and the Starship HLS, which HLS is Human Landing System. And, of course, Starship is the machine that we've seen recently having test flights powered into orbit, in fact, by the Falcon Super Heavy booster, which made that spectacular landing last month. This month's being grabbed by the chopsticks. So all that's got to come together to ensure safe and accessible landing sites. The Artemis 3 geology team, I'm still reading, evaluated the landing regions for their scientific promise. Sites within each of the 9 identified regions have the potential to provide key new insights into our understanding of rocky planets, lunar resources, and the history of our solar system. So it's really big picture stuff, and all of that feeds into the decision as to where you put the next landing site on the moon.
Yeah, and I'm guessing there's strategic value in being on the North or South Pole. Is it icier, therefore you can get water, therefore you can make rocket fuel?
I think that's it in a nutshell, Andrew. The South Pole is a place where we know there is water ice from orbital measurements, and actually an Indian spacecraft that was it an Indian one?
Yeah, I think so.
I think
is that the one they lost contact with?
Yeah, it crashed into the surface, and you could see water, the signature of water in the plume that resulted from that. So yes, that's what sets the South Pole apart from the North Pole. It's actually much rockier, much more cratered, and the craters are deep enough that we think there is what you might call primordial water that was dumped there by comets. You know, it's the water that was originally in the gas cloud that formed the solar system. So quite a legacy.
Would you like to get hold of some of that and melt it down and have a drink?
Well, I think we did a discussion about that, didn't we? About whether it would be drinkable. I'd be up for it. Yeah, I'd be game for a bit of moon water. You never know what it might do to your insides, but hopefully I grow some antennas or something like that.
Maybe, or you'll turn into cheese. Who knows?
I'm already cheesed, you know that. Very cheesed.
You mentioned India, and that just sort of prompted a memory, a thought in my mind. Hugh in the studio messaged me the other day to say we've picked up some strong audience indicators from India. So hello to all our Indian listeners. Believe it or not, I will be in India in about a month. So I'll look out for me. I'll be wearing this shirt.
He's only got one shirt, folks.
It's the only shirt I've got. So yes, I'll be visiting several places throughout India while I'm over there. So that'll be lovely. But if you're in India, salutations. Thanks for watching, and sorry about the cricket. Yeah, they got hammered by New Zealand. Lost
that's
home.
right.
Yeah,
yes,
unheard of. And then they've got to follow that up with a tour of Australia. So but we haven't won the trophy from them in quite a long time. So this will be a key series for both sides. So looking forward to that. My favourite sport to watch on TV is cricket.
Yeah,
love it.
I get that.
Yes. So Artemis 3 landing sites, but we still don't know when, do we?
Late 2026 is my guess, I think, for that crewed landing. Late next year for Artemis 2, which will be a crewed flight, but won't land on the moon. It'll go around the moon.
It'll do an Apollo 8.
Apollo 8.
Hello.
Right.
Oh, there it is. Bye.
Yeah, bye. Except it's
on
Apollo 8
Christmas Day it was.
It was. I remember it well. Yeah. 1968.
Yeah.
Yep.
Gosh, so long ago. Yeah. Okay. If you would like to look into that little story about the Artemis 3 landing sites, it's on all sorts of stories, but you can get it at spaceconnectonline.com.au. This is Space Nuts with Andrew-dunkley and Professor Fred Watson.
0G, and I feel fine.
Space Nuts.
Now, Fred, we're going to revisit the asteroid Ryugu, which we've spoken about a couple of times, but it's in the news again because they've been able to do a bit more study on the stuff that was brought back. I think it was a Japanese mission, was it not?
Yes, that's right, indeed.
And they have found out some interesting things, and it all sort of leads to piecing together the puzzle of life on Earth.
Indeed, it does. And so it was JAXA, the Japanese Space Agency, whose Hayabusa 2 mission collected samples from Ryugu and returned them to Earth in 2020. And in fact, we in Australia played a part in that. The Space Agency had a role in that because I think I'm right in saying that they returned to Earth not far from Woomera in South Australia.
That's right. No, I thought
yeah.
it must have been a different mission where I thought, we just made the sausage rolls for the party afterwards, but it's okay.
Yeah. Yes, that was Osiris Rex, I think, that you're thinking, which was a NASA mission. And we did make the sausages, yeah. But 2020, that's 4 years ago. It takes a long time to analyse these samples and get the detail. But there is some really interesting news from one of the French universities, actually, where some of the researchers are based, along with some researchers from the Open University in the UK. And it turns out that there are grains of something that is called HAMP. Not hemp, it's HAMP.
You preempted me.
Yeah. Yeah. And HAMP is an acronym for hydrated ammonium, magnesium, and phosphorus rich, and phosphorus. Yeah. Hydrated ammonium, magnesium, and phosphorus, HAMP. And it turns out that is a compound that is highly soluble in water. And if you're trying to get nutrients into, living organisms that are formed on a water base, and all life on Earth is water based, then this is a really important way of doing it, to have something that will easily dissolve. And so the suggestion is that we know that these asteroids, like Ryugu, are remnants of the early material of the solar system. They're the sort of scraps of dust that were left over when the planets formed, and it's the raw material of planets that we're looking at, really. But it means that if they are rich in these hydrated ammonium, magnesium, and phosphorus, and that's basically a soluble thing, maybe in the very early Earth, when it was being bombarded from all sides by asteroidal material like this, maybe that's where these chemicals came from that provided nutrients for any early life forms. Basically, as SciTech Daily, which has reported this, as they say, creating the right conditions for life to emerge. I might quote, actually, if I may, from Dr. Richard Greenwood, who's at the Open University in the UK. Richard says, our study reveals how the building blocks of life were likely transported from the outer solar system to Earth. Material returned from primitive asteroids like Ryugu is providing new insights into how our home planet was transformed from a barren, inhospitable world to a water-rich oasis containing all the ingredients needed for life to emerge. Very nicely put.
It's sort of like I always equate life to being always out there and potentially available if the conditions are right, if the place is right, if everything's right, life will find a way. And I back that up with how weeds will grow just about anywhere they damn well like. But it's true. Like I've seen weeds growing in the weirdest places, but they got a foothold because the conditions were right and they found somewhere to grow. And I think, you can take that little weed analogy and turn it into a planetary, evolution. I honestly believe that. And I think everything, all the formulas that exist to create life exist across the universe. It's just a matter of finding somewhere to plant it. And we just happen to be the only place so far where we can confirm life exists. It's not very bright, but it's here. We are here.
It's got lots of hemp as well. Sorry, hemp, not hemp.
Yes.
No, I think you're probably right. It has to be said that we simply don't know whether that's the case or not. But that's, I think, a very plausible assumption. I think it's a reasonable thing to assume that if the conditions are right, life will start.
I'm just turning my fan on because it's getting quite warm in my office today because I think we're going to hit 30-something degrees today and it's starting to magnify through my window. But Ryugu's probably been a keystone mission in trying to solve these riddles of life, and it keeps, as you say, keeps coming up with new information the more they study it. When they first got the samples back, they went, "Oh, it's dirt in a Kit Kat wrapper." So they've come a long way in 4 years.
I wonder if anybody's analysed the Kit Kat wrapper. That could be quite interesting.
That adds more weight to string theory, I think, maybe.
Oh, it would. Yes, it certainly would. Yes.
Is there more to learn from Ryugu?
I'm sure there's ongoing research. We've learned a lot about it, not just what it's made of, but we've learned a lot about that particular class of asteroids that Ryugu is a part of. It's a rubble pile. Just the images that came back from it showing this object shaped like an old-fashioned spinning top that was sort of like two cones back to back. And that now we think is the characteristic shape for rubble pile asteroids. So all that sort of thing comes from the studies that have been made. I think though there's probably still more to come from the soil samples too.
It also suggested that Ryugu could be evidence of how Earth got its water. We've talked about this many times because there's all sorts of different theories about where the water came from. It's possible all of them are correct, but one of them was the fact that as the planet came together, all of that stuff already had water in it, which eventually leached out and became the oceans and the ice caps and everything else.
I think you're right. I think it is a mixture of that plus, comets coming in and dumping water into the Earth's environment, to the planet. So I think, and I guess what supports that is we know that the isotopic ratios on Earth's water, the ratio of normal water to heavy water, don't quite match most of the isotopic ratios in comets, except in a few cases. So there's obviously a mix at foot, a mixture of foot there as well. So I think you're right. I think it's probably a combination.
Interesting. All right. Yes, lots has been learned from asteroid Ryugu, but there's probably more to come. But it certainly seems that it's carrying evidence to show that we are here because of those kinds of collisions in the deep, dark past. And if you'd like to read about it, it's, as Fred said, on the SciTech Daily website.
3, 2, 1.
Space nuts.
And that story dovetails beautifully into our final story, which is also on SciTech Daily. And this is some information they've uncovered about the moon Titan, which is one of Saturn's largest moons. And what they've found out, and this I'll steal straight from the headline, could rewrite planetary science, Fred. That's a big call.
It is, yes. It's but it's really interesting results. And you're right, Titan is, it's the largest of Saturn's moons. It's the second largest moon in the solar system after Ganymede, which is Jupiter's biggest moon. So what's the story here? And this comes from research carried out by scientists at the University of Hawaii at Manoa, place I know reasonably well from when I used to have to observe on the summit of Mauna Kea there back in the day. These scientists have noted that compared with moons like Ganymede, Titan has fewer craters than Ganymede by a long shot, and also that they are the ones that are there, and they can only identify 90 of them, and that's much less than Ganymede and most of the other moons with craters. It shows that of the craters, of the 90 craters that have been found on Titan, it turns out that they are much shallower than what you would expect and what you find on other moons. So you've got few craters, and the ones that are there are shallow. And so what these scientists have done is put those two facts together One of the scientists is quoted as saying, "This was very surprising because based on other moons, we expect to see many more impact craters on the surface and craters that are much deeper than what we observe on Titan. We realized something unique to Titan must be making them become shallower and disappear relatively quickly." And that's at the heart of what planetary scientists do when they look at a surface of the moon or a moon or a planet. It's the number of craters that you can see that tell you how old the surface is. The older the surface, the more craters you've got. So the moon is certainly the South Polar region where it's heavily cratered. That's a very old surface indeed. It goes back to the first billion years of the solar system. And yet on Titan, we're looking at something quite different. Now, we know that ice worlds like Titan, and by that I mean a world that is a rocky core, an ocean overlaying it, and ice overlaying the ocean. Worlds like that do tend to have relatively recent surfaces because the surface is constantly being modified sometimes by plumes of ice that come up through cracks in the surface, as we find on Enceladus and Europa. But also just because of the fact that if you've got an icy surface, it's subject to different geological processes from what rock would be. It doesn't preserve structures anywhere near as well. But on Titan, and Ganymede too has an ice surface. We believe that it's an ice world as well. Yet it's got far more craters than Titan does. So that's a really interesting judgment that's been made. We realize something unique to Titan must be making them become shallower and disappear relatively quickly. And so what they've done is they've done a lot of computer modeling and sort of suggested that maybe there is an insulating layer on the outside of the ice. And what they're pointing to is something called methane clathrate. Clathrate is basically methane. It's water ice, but with methane gas trapped in it, which gives it a different formation and different properties. So it's much more of an insulator than the ice would be. And so they've modelled it, and they find that the likelihood is that there is a layer of methane clathrate, a crust, which is 5 to 10 kilometres, 3 to 6 miles thick, because that produces, the computer simulations, that produces the crater depths that are actually most like the ones that we find in reality.
And are they suggesting that the atmosphere of Titan is coming from deep inside with an insulating layer of water ice? Did I read that correctly, or I got my wires crossed?
I think there's certainly a comment in the article that I've read that, and in fact I might quote from it. This is from SciTech Daily. They say, estimating the thickness of the methane ice shell is important because it may explain the origin of Titan's methane-rich atmosphere and helps researchers understand Titan's carbon cycle, its liquid methane-based hydrological cycle, and changing climate. It's a really interesting world because we can study climate change, from the outside. Another quote from the lead author in this paper: Titan is a natural laboratory to study how the greenhouse gas methane warms and cycles through the atmosphere. There you go.
Yeah, I highlighted that exact quote, and they even compare what's happening on Titan to what's happening in regard to the permafrost of Siberia. So even on Earth, we're witnessing these kinds of cycles.
Yes, that's right. And once again, it points to. I think it enhances the possibility that we might find life in Titan's liquid water ocean, because the temperature is probably a bit higher than we thought it was, because it's got this insulating layer on the outside. So yeah, exciting stuff.
Oh yes, that would be a thrill to find life on Titan. Of course, they've got some missions slated for studying Titan's undersurface ocean and look for biomarkers and learn more about it. It's pretty exciting time. Of course, we've got missions. Europa Clipper's on its way.
Yeah.
Yeah. There's so much to learn out there, and you just never ever can say no. There's no life anywhere else, because there might be something there. We hope we find it, or at least indicators of it.
Yes,
we've found indicators of potential life, have we not? I mean,
yeah. Which, but that's the trouble. What we call biomarkers, these indicators, they're not. It's really hard to pin them down to be things that can only occur because of life, rather than through normal sort of chemistry rather than biochemistry.
Indeed. All right. SciTech Daily, again, as we mentioned, is where you can read up on that story of Titan, although I've noticed that the story's been popping up on all sorts of news platforms, because it's pretty exciting to find out something that might be a bit different than what we first thought. So you might want to check that out. That brings us to the end of the show. Fred, thank you. And, not only for today, but for the last 500 million years that you've been doing your job. It must feel like that. Yeah. I only did 22 years in the public service, and it felt like a lot longer. But looking back, it just happened so fast,
That's right. I have to say, Andrew, I've not been a real public servant, because I've been an astronomer first and foremost. But I'm paid from the public purse, and that makes me a public servant. It's mixing with real professional public servants, as I have done over the last 6 years, that teaches me a lot, actually, about how the public service works and what I should have been doing for the 45 years before that.
It generally works with an 8-hour coffee break when you get to work, and then you can go from there.
I won't go there, no.
You can tomorrow.
Yes, I can tomorrow, yeah, that's right.
All right. Thanks, Fred. We'll catch up soon.
Sounds great. Thanks, Andrew.
Professor Fred Watson, astronomer at large, and thanks to Hugh in the studio for keeping it all together. Because if there is a problem, Hugh's name is spelled H-U-W, and we just type H-U-W-S-T-O-N, we have a problem. Figure that one out. And from me, Andrew-dunkley, thanks for your company. Don't forget to check out our website, check out our social media platforms, check out our shop, all via our website or Facebook or Instagram or whatever. And we'll catch you on the very next episode of Space Nuts soon. See you then. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.